Okay, in this video and the next one, we want to try to tackle some problems where we're taking derivatives with exponents, where the exponent is a variable. Suppose, for example, we had this equation, y equals a raised to the x power, where a is a constant, but y and x are both variables. And this obviously is different from the other types of problems that we've talked about so far. You know, if it was written like this, y equals x to the a power, and we want to find dy dx, well, that would just be a times x to the a minus 1 power. And if we wanted to do a formal, we would say times dx dx. And that's 1, so we don't typically write it down, but we just take the power that it's raised to, that constant number, put it here, and then it's x raised to that minus 1. We've done it many times. But here, we have a constant being raised to a variable power. And now we want to try to find dy dx. And the trick is to use the techniques of logarithmic differentiation. If we have an equation in this form, we can say that the natural log of y will equal the natural log of a to the x power. And now, using the property of logarithms, we can rewrite this. This would be equal to x times the natural log of a. Now, let's take the derivative of both sides of this equation here with respect to x. So we would write the derivative of the natural log of y with respect to x, that will equal, now let's take the derivative of this side of the equation. The derivative of this with respect to x, that would be this, times the derivative of that, which is just dx dx, so that's just 1. So we have this times 1, plus x times the derivative of this, but this is a constant, so that would be 0. So we say that the derivative of the natural log of y with respect to x equals the natural log of a. But here, looking at this, we can use our technique of logarithmic differentiation, and we can write this out further. We would say that d dx of the natural log of y, that's equal to 1 over y dy dx. That's just our logarithmic differentiation, and that has to equal the natural log of a. Or multiplying both sides of the equation by y, we would say dy dx equals y times the natural log of a. And we look back up here, this is what y is. So we can say dy dx, y equals a to the x power. That's what we started out with. So we can say dy dx equals y, that's this, a to the x times the natural log of a. And there's our answer. So, when y equals a to the x, dy dx is equal to this times the natural log of whatever constant we have here. And that's it. There's no more to it than that. The whole trick is to, looking at this, is to express it in logarithmic form, then take our derivatives. And we remember how to take logarithmic derivatives, and that's when dy dx pops into the equation, and we can easily solve that for dy dx. It's just y times the natural log of a, and remember at the beginning what y is equal to, and there's our answer. So it's a little bit roundabout way of getting there, but it can be done, and it is a pretty simple formula. Here, y is equal to this. The derivative is just this times the natural log of a. No problem. Let's see if we can tackle something maybe a little bit more involved before we close out the video. Suppose we have this. Y equals a to the, say, x squared minus x power. And we want to find dy dx. So again, we take the natural log of both sides of the equation. We have the natural log of y equals the natural log of a to the x squared minus x power. And this equals, using our property of logarithms now, this x squared minus x times the natural log of a. So the natural log of y, that equals x squared minus x times the natural log of a. So let's see. Let's go ahead and take derivatives of both sides of this equation with respect to x. So we're going to have the derivative of the natural log of y with respect to x. And we know what this is. That is 1 over y dy dx and that has to equal the derivative of this side of the equation with respect to x. So we can have this times the derivative of this quantity right here, so that would be the natural log of a times this derivative, which is 2x minus 1, and then we would have plus this quantity times the derivative of this, but this is just the log of a constant, which of course is a constant, so that's 0. So here we have then that dy dx that equals 2x minus 1 times the natural log of a, and we have to multiply both sides of the equation by y. Here's dy dx. But what is y? Y is this. So we're going to have dy dx will equal this 2x minus 1 times a to the x squared minus x times the natural log of a. Y is this, and here we're just plugging in what we already had. 2x minus 1 times y, that's this, from up here, times the natural log of a. So y equals a to the x squared minus x dy dx then equals 2x minus 1 times a to the x squared minus x times the natural log of a. Now if you had just looked at this, should this be obvious? Not at all. We have to use the technique of taking the log of both sides of the equation and doing our logarithmic differentiation. Once we do that and just kind of follow through, then the answer pretty much just pops out for us. But that's it for this video. Come back and join us for some more videos, and we'll see if we can solve some more problems.